All right, so far in this chapter with Mrs. Russell, you guys have looked at angles and points and all the properties of stuff so that we can finally start and put it all together and come up with geometric shapes. So our first geometric shape is the triangle. Definition. What is a triangle?
Shape that has three sides.
A closed, three-sided geometric shape. That's a good start. A triangle is a closed, three-sided figure. It's just assumed it's geometric. It has to be. Figure. And what do we know about the angles? Very good. Whose angles add to 180 degrees. This is the shortcut for angles right there. So I don't have to write it out. Angles add to 180 degrees. That means all triangles. Doesn't matter what it looks like. We'll have if I take all three angles and add them up, it's 180 degrees. We're going to use that a lot. So that's important to know. Classifying triangles. That's the other thing we're going to do. Now, when I say classify, that means just naming it. But that's important because what we'll see is if we know something about the triangle, especially the lengths, certain things are going to happen with the angles. First kind, scalene. Scalene triangle, all three sides are different lengths. That's why it has, each side of this scalene triangle has a different number of tick marks. That's the lines going through the sides. Those are called tick marks. Next one is isosceles triangle. An isosceles triangle's two legs are congruent, means they have the same length. So you see those two, these two sides here and here have two tick marks in them each. That means they're congruent to one another. And the last kind of triangle is equilateral. All three sides are the same length. All three sides are congruent. If I go too fast, when I'm turning, you may politely ask for me to slow down, and I will gladly do so. Keyword there is polite. The mute is on. Okay. The other way we're going to classify or name triangles. Good to go? Okay. The other way we're going to classify triangles is by the measure of the angles. First one is an acute triangle. In an acute triangle, all angles measure less than 90 degrees. A cute little triangle, because it's got cute little angles in them, less than 90 degrees. That's the mnemonic device. Thank you, Mrs. Hennon. Still sticking with me 20 years later. Obtuse triangle. An obtuse triangle has exactly one obtuse angle. Now, why am I being that precise to say has exactly one obtuse angle? Can a triangle have more than one obtuse angle? It would not be a triangle. It would be very weird, but it would not be a triangle. You couldn't close it then. It has exactly one obtuse angle. You would have something with more than 180 degrees. If it had more than one obtuse angle, it would not be a triangle. And a right triangle has exactly one right angle. For the same reason, an obtuse triangle has only one obtuse angle. If you had two right angles, you would have a line. You would not have a triangle. We're going to continue classifying by angles. Look at that isosceles triangle. What makes it isosceles? There's nothing about the length of the sides in there. But what about their base angles? Those two angles there are, no, well, yeah, they are congruent, right? Their angle measures are the same. So look at this. This is isosceles triangle because these two base angles are congruent. And because it's isosceles, what do I know about those two sides? This one and this one. It's isosceles, so they have to be, yeah, they have to be congruent. This is the working backwards part. If you're given one part, you can go and do something else, which means, what if I look at this isosceles triangle, what can I say about these two base angles right here? They're congruent because that's an isosceles triangle. So, definition, isosceles triangle, the base angles are congruent. That means the two angles at the bottom of the congruent sides. This is an equal angular triangle. That means all three angles are congruent. So if all three angles are congruent, what is the measure of each one of these angles? Nope. 60. 180 divided by 3, right? Because each one of these has to be the same. So each one of these angles is 60 degrees. In an equal angular triangle, they all three have to be 60. What else does that triangle look like it is? Does it look like something we've already talked about? It is. Yes, it looks like equilateral because it is. If a triangle is equal angular, it is also equilateral. Which means that if it's equilateral, it's also equiangular. And all three angles are 60 degrees. Angular. So I could go here and say that one's congruent to that, congruent to that, congruent to that. I can fill that in. So it works both ways. If I get one, I definitely have the other. And the reason why that is if you look in your textbook on page 207, is property 3, which we'll get back to at the end of the lesson. Property 3 says this: in a triangle, the largest angle is opposite from the longest side, and the smallest angle is opposite the shortest side. Well, if that's true, all three angles are the same. That means their opposite sides have to be the same length as well. That's that property 3 today. Prop 3. We'll use it a little bit today. That's why in an isosceles triangle, the angles opposite those sides are the same because their opposite sides are congruent. And Brittany looks thrilled. I'm glad you're so happy about that. Thank you. All right. Now we're going to start put some of this stuff together. Some of the resulting effects of those properties and rules of triangles we have. One of them is this: if you have a triangle, if you take any two sides of that triangle and add them together, they must be bigger than the third side. The sum of two sides of the triangle has to be bigger than the other side. If it's not, then you don't have a triangle. I'll show you. Here's what it means to us. If I take any of these two sides and add them up, it has to be bigger than the third side. Otherwise, I don't have a triangle. Well, how do I do it? There is a shortcut to doing this. Take the two smallest sides and add them up. If they're bigger than the other one, then it has to be a triangle. What's 9 plus 16? 9 plus 6, I'm sorry. It equals 15. Is 15 greater than 14? Yes. So yes, that is a triangle. I will prove it to you. I'm going to prove it to you two different ways even. 8, 5, and 3. If I had a triangle with lengths 8, 5, and 3, would it actually form a triangle? What's 5 plus 3? Is 8 greater than 8? No, it's equal to 8. So is that a triangle? No, I'll prove it to you. Nope. If you had an equilateral triangle, you could have 2, 2, and 2, right? 2 plus 2 is 4 is bigger than 2. See, now this one's 8, this one's 5, and that one's 3. Do we see that? Now, it doesn't matter what the units are. Centimeters, millimeters, inches, miles, whatever. Kilometers. Could be anything. If you have lengths 8, 5, and 3, I'm going to try and make a triangle with this right now. The hard part is keeping the lengths the same. So I got to bring my ruler over here and measure. Oh wow, that one I did pretty well. That's still right around 5. Okay? That's alright, I'll measure it. Make sure. Those are 8, 5, and 3. Did that form a triangle? Okay, what could I do? Could I make this angle here? Could I make this angle right here smaller? Yeah. Alright, let me try that. But the thing is, the length still has to stay 8, doesn't it? Yeah. So if I change that, let's make sure it's still 8. It is. It's still 8. I'd have to, what? Swing that out, wouldn't I? In order to make it a triangle, this one has to come out. So will it work? Will it ever be a triangle? No. I mean, I could... The only way to make this a triangle is for me to go like this and close that. But look, the length of this side right here, the red one, is no longer 8. It's 6.5 to that closed point. So it is impossible to make a triangle with lengths 3, 5, and 8. I've just shown you. If you take any two sides, add them up, it has to be bigger. Cannot be equal to, cannot be smaller than the third side. Otherwise, you cannot make a triangle out of it. Let me prove it to you another way. Here are 3 dots. They will, if I connect the dots, they'll form a triangle. What's the shortest distance between any 2 lines? Straight line. What's the shortest way between 2 points? Straight line. So to go from A to B, that's there. Then to go from A to C, it's this red one right here, right? And then to go from C to B, right there. If I take these lines out individually now, and I put any 2 together, what's going to happen? Those lengths will always be longer than the other one. Right? If I put those 2, see it's longer than that one. I can put these 2 together. It's longer than this one. Or I could take these 2 together and it's longer than that one. Has to always be that way. So, you have now seen and it's been proven to you when you have a triangle, the length of 2 sides has to be bigger than the third, the sum of those 2. Alright. Now we're going to get in some of our other properties. We know there's 180 degrees in a triangle. So if I want to find the measure of angle BCA, so is this the angle that's inside or outside? Inside. It's this angle right here. That's BCA. What's the exterior angle called? Well, how would I name that? What would this one be? Angle... Nope. BCF or FCB. You can name in any order. BCF. That's the exterior angle. So how would I find the measure of this interior one? What I'm going to do, go ahead. And subtract from 180, right? You know, there's actually 2 ways to do it. And I'm going to show you another way. Yes, the most intuitive one, the way we already know, and it works. Add those 2 together. I get 108 degrees. Subtract that from 180. Huh? Oh, 102. It is 102. 78. Yeah, I was thinking 78 was this. So I combined my answers, 78 and 102. Yes, it is. It's 102 degrees, so 78 here. So the measure of this angle is 78 degrees. So we're going to find something out right now about this measure of this exterior angle, BCF. So now that we know this is 78, what do I know about this entire part right there under red? It equals 180. It's called a straight angle, right? A line has 180 degrees. Well, if this is a straight angle, and this is 78 degrees right here, what's this right here? 102, right? 180 minus 78. It's 102 degrees. Well, where else do I see 102 degrees? It's the sum of those two, right? So, definition. If you take any of the line segments and extend them on a triangle and form an exterior angle, the exterior angle formed is equal to the sum of the other two non-adjacent angles. That's easier said than, yeah. It's even worse. This one is property 4, and it's worse than the book. If one side of a triangle is extended, then the exterior angle formed is equal to the sum of the two remote interior angles of the triangle. What that means is if you have an exterior angle, the measure of this one is equal to the sum of the other two that aren't next to it. So you add up those other two, and I just showed you. 20 plus 82, 102. We used that 102 to get that 78. Well, that has to be 102 because this is 180 degrees in a straight angle. We're going to use that property right now. Does it matter which one I find first, x or y? No, I can find either of them. What do I have to do to find both of them? Add 65 and 68. All right. 65 plus 68, 133. Well, that I know right now just from what we did, that's what x is. That's 133 degrees because these two angles are the other two that's not next to it. Now I use that 133, take it away from 180, 47. 47 degrees. So y is 47 degrees. That's not bad, is it? Simple arithmetic. Yes, eventually. Just like that. No. How are we going to do this one? Haha, you can't. Till I do this. Can you do it now? Yes. What do I know about this angle y and this one right here? They're congruent. What do I know about their angle measures? Measures are equal, angles are congruent. It's me being picky because I choose to be, all right? Very good. So to find this, I have to take the one I know. There's 180 degrees inside here. I can't add these two up to get x because I don't know what y is. So I take away 50. I get the 130 that's left for these two angles. Can I figure out what each one? Yeah. Since they're congruent angles, I know their measures are the same. Two of them are the same. I can break these into two equal units by dividing by 2. Gives me each one of these is 65 degrees. So that, whoa. Oh, that Mrs. Russell. She went and changed that on me. Oh, I'm going to have to take that up with her. 65. Well, do I even need to figure out what this one is to get x? No. 65 plus 50? X is 115 degrees. That's using that exterior angle property, which is property 4. Prop 4. All right, now we're going to put it together. And this is what geometry is all about. Using my rules, we're going to work around and work through some stuff. All right, let's take the information we have. Whenever I approach a problem like this, the first thing I want to do is say, what information do I have? I put it into my problem, then it'll make it easier to figure out. Measure of angle 1 is 33 degrees. The measure of angle 5 is 24 degrees. What's that one? 90. It's a right angle. Find the measures of the other angles. Okay, well, it's really not that bad, is it? In triangle FRD, I know this one's 90 and this is 33, so I can figure out that one by adding those two together, right? Well, as soon as I add those two together, what else do I know? That's what 3 is, because that's my exterior angle. So I'll do that first. All right, measure of angle 3 equals 123 degrees. Got that one just like that. Take that away from 180. Very good. Guys are rolling right along. 57. That's 2. See how quickly this can come together? Slow down, slow down, slow down. Where'd I lose you? Okay, I was given that and that and that, right? See how this is an exterior to this inside triangle here? Well, that means if I add the 2 that aren't next to it, that has to give me what that is. All right, got that one. Now, inside this triangle, I have this one and this one. So I take that away from 180, and that gives me that one. Good. Now we're down to our last one, right? How do I figure out 4? Yeah, same way I figured out 2. This is a triangle right here, DRP. So this one plus this one, take it away from 180. Yeah, see how it's the same stuff over and over again? Aha, 123 plus 24 is 147 degrees. Take 180 minus the 147 gives me 33 degrees. Aha, so what do I know about angle 1 and angle 4? They're the same, they're congruent, which means if I look at this big triangle, FRP, what kind of triangle is FRP? It's isosceles because the base angles are congruent. Which means I could then go on and say, hey, that one and that one, those lines are congruent. I could say FR is congruent to PR because it's isosceles. We'll get to that stuff. This is where we're going, right here. You just had to get the angle measures for this one. But yeah, you look at the end, hey, 33 and 33, I got base angles congruent. That means I have an isosceles triangle. One more thing. Property 3. Property 3 says this. Longest side, opposite, largest angle in any triangle. The longest side is opposite the longest angle, which means the converse, inverse, the inverse, converse. Converse is true. The opposite. If the longest side is opposite the largest angle, that means the shortest side is opposite smallest angle, right? So, shortest side, opposite smallest angle. Right? Right. So now we're going to list these. Now when I mean opposite, I mean you go across. What's the shortest side? What's the smallest angle there? 40. See how that's 40 right here? What side is it opposite? FG. So FG is my shortest side, but look, it's also opposite this 50 right here, right? So that takes care of that 40 and that 50. What's the next smallest angle? This 50 right here. What is that opposite? FE. See how I'm just lining them up? I'm just going to go to the next biggest. It's opposite that. Or EF. You cannot go by what it looks like. You cannot go by what the lines look like. What? Okay, what's the next large? What's the number that's next biggest? 55. What side is opposite the 55 degree angle? Opposite. HG. So HG is next. What's the next biggest angle measure? 75. What side is 75 opposite? HF. HF is next. Which means what one's left? The 90. What's the longest side? GE, we bring good things to life. Now we have listed them from shortest side to longest side. You might see something like that on an upcoming test. Don't mess it up. I guarantee you there's a problem similar to that with one triangle. All right. 208 and 209, 1 to 30 all.